Maybe a good way to get started with the video is to just go down the line and have each person introduce themselves and just say a few words about what their role was in scientific data systems. Why don't we start with you,
Since I'm at the end of the table.
We'll start at the end of the table.
My name is Pete England. I was the second programmer at SDS, hired by Emil. And I wound up doing, in the very early days, a lot of programming related to making the hardware work. I also had strong opinions about hardware how it ought to be developed to make it easier for me as a programmer, because I had been at Packard Bell and had problems with what the engineers had developed. So I always characterized my time in the early days as trying to move upstream and influence what was being built so that it would make it easier for me to do my job.
Very good. Were you doing diagnostic programs?
I did diagnostics, I did utilities, I did basic octal loaders, the things that allowed us to get going on the machine. But I had strong opinions about other things that the machine should do that would make it easier for me and other programmers to actually do something useful with it. I think, to a great extent, my opinion, the engineers were trying to make sure they could make a product work. I had no doubt they could make it work. I just wanted them to make it work easier for me. And eventually that led me into what has come to be called architecture of computers, which occurred later with the Sigma series.
All right. Good.
I'm Don Cooper, and I was hired by Max to do the...
Now, could you just tell us where you came from?
I was...
or where Max found you, or how you joined
Max found me at Packard Bell.
You were at Packard Bell also.
Before that, Max found me at the IEEE show in New York City in, I think it was about January 1959. I was currently looking for another position, and I went to the IEEE show figuring I might find something there. And I was wandering around, and I came to this little booth. It was sitting on the corner. There was nobody there manning it, and there was some interesting looking equipment there with analog digital converters and stuff. So I started opening up the racks and looking in behind, and felt this tap on the shoulder and looked around, and it was Max. I didn't know who he was at the time. And he said, can I help you? We got talking, and he said, well, what are you doing? Who are you working for? I said, well, I'm looking for another position. And he said, well, we're looking for engineers. And so to cut a long story short, that's how I came from Toronto, Canada to Santa Monica, California.
Okay. And you were employee which?
Sorry?
You were employee number?
I think 70 at Packard Bell.
No,
and then from, well, the question was where did they come from before? So
yeah.
So from Packard Bell, then later on, when SDS was formed, I went there, and I think I was number 5.
Well, we were parallel.
Yeah.
We were parallel number 1.
Yeah, one, 2.
All right. And what was your role in the
so
beginning?
my role was to work with the logic designers to take what they had come up with, partition it into modules. You see the circuit cards that are in the machines out there, and so we had circuit cards for different functionals. We had AND gates, NAND gates, OR gates, flip-flops, and so forth to create the digital circuitry that could then be configured and wired on the back panels to create the computer.
Mm-hmm.
And then later on I moved into some of the peripherals, like we had kind of an ongoing experience with paper tape photo readers, because prior to that time most paper tape readers were mechanical, kind of like they have on the teletype machine. And the early photo optical paper tape readers had a lot of different problems. And so we spent a lot of hours trying to figure out better ways to make them work.
All right. Good.
And I tried to program them.
Yeah, my name's Emil Borgers, and I was one of the 5 of us that started the first day, I think. That's probably correct?
Pretty close,
Yeah,
close enough.
right.
Okay.
We would have numbers by alphabetical order or something like that.
No, I started a week late because I took a vacation
Yes,
from
you
Packer
did.
Bell.
Yes, you did. I
Now,
remember.
You were also at
Dean
Packer Bell?
Wallace.
You were also, Emil?
Packer Bell, Packer
We
Bell,
all,
Packer
at-
Bell,
at-
Packer
at-
Bell.
we all from here on, well, including Bob.
And Bob.
Only
Everybody.
Arthur was
So
not
six
Packer
of
Bell.
the 7 here were Packer Bell.
Okay.
I can remember Dean Wallace asking you if you were going to leave.
Right.
He's one less, yeah.
Remember that?
I
Huh?
remember.
Do you remember that? And he didn't answer.
No, I did. I did.
Did you?
This
Did
is
you say
from,
no?
from Packard Bell after I had committed to start with Scientific Data Systems. And I took a 2-week vacation. My name is Jack Mitchell, by the way. And
They got it signed here.
oh, do they? The new guy who was running Packard Bell called me at home because there was panic at Packard Bell because all the best people were leaving to go to work for Scientific Data Systems. And he said to me, I want to
Some
make...
unnamed place.
Right.
Because it wasn't, we didn't have a
He
name.
said, I want to make an announcement that you're not leaving Packard Bell. And I said, well, I wouldn't do that if I were you because I'm planning to leave as soon as my vacation's over. He said, well, can I make an announcement that you haven't yet left? So I said, well, of course, go ahead.
That's what he did.
So continue.
All right,
Okay.
yes, and
Okay, well, Pete left out something. He and I were working on what machine we would build at Packard Bell if we could have our choice. So we had some thinking going on as to what we really wanted to do. And in the business plan for Scientific Data Systems, we created an idea of what we wanted to do. And at that time, we wanted to build 3 computers. The idea being that when a salesman walked into a customer, he didn't know how much money they had. So it's better to have more than one offering. Remember that, Max? More than one offering so that you can close a deal with them. So you have something that they can afford. So we created the concept of the 910, 920, and 930. Turns out,
A different 930.
well,
okay.
it turns out that we couldn't afford to do 3. But we could afford to do 2 if we designed the higher one and left out some stuff out of the lower one to cheapen the price, which is really what we did. I think some of the original concepts that we had in there was the idea of creating, as was mentioned in the speech, a way of micro-programming, which wasn't even defined at that time, so that we could write one software package and have it work on both machines. A little slower on the cheaper one. And it worked. That worked. Another thing that we had in our computer, and all 3 of us, Jack and Henry Harrell, who's dead, and myself, came up with was the priority interrupt system, which far exceeded anything that anybody could ever do up to that point. And the primary advantage of it was the reaction time of the computer, recognizing the outside event and being able to quickly satisfy it. And that, was a big advantage in the real-time world. I think, I was mentioning to Max before, one of the things that most of us, we all had experience in other companies, and we had to keep cleaning up other people's problems. But what he offered us was a chance to clean the slate, and we had to, not complain about anybody else. We just had to do it. And it worked.
good. And your general area of responsibility in the first
Programming.
couple of years? Programming.
At the beginning was computer design, and then programming. Actually, we wound up with in my time there, with over 100 programmers that were very talented.
Okay. Jack?
I worked at Packard Bell for Max. I was the director of computer engineering at Packard Bell. And then when I went to SDS, there basically were 4 of us working on the computer to begin with, other than a memory design, which were those core memories. And Don was doing the computer design, the circuit design. Emil, I, and the now deceased Henry Harold did the design, the logic design, and the basic concept of the 910 and 920. And it was a wonderful period because we each felt that the other was smarter than ourselves, the other two. And so it was exciting working with those people and creating something completely new. And then once we had the design of the 910 and 920 done, my job became building them. And so we hired a couple of wonderful technicians.
Ace Garcia.
Ace Garcia and Hig Shiriyama were their
That's
names.
right.
And then there was a question, we didn't have enough drafting help to get the drawings made, the logic diagrams made for the computer. And so I had seen in some ad somewhere these items which were 8 by 10 peel-off sheets, which were very new at that time, that were transparent. And so we had the circuits of the modules, those that Don would permit us to build. We always wanted new and different ones, but his orders from Max were, you've got to limit the
Keep it
number of
simple,
modules, and he was very adamant in that regard. But we printed those things on these sheets, and then we took blank vellum, and we would cut off that portion of each board. We would number the sticky sheet with the location where that module was going. And then we would cut out that portion of the module, those circuits within the module, which we were using. And we would then paste those onto the blank vellums and draw lines in between them to create the drawings without draftsmen. And then from there, the problem was getting a wiring list from those sheets, which we did on index cards. And then the problem was, once we got going, we had a larger number of people who were wiring different machines, and we didn't have enough index cards. We'd say, okay, you do these, and take them out of the single box in which they were. And finally, of course, we got those copied off so that the people could do the wiring. And then, after that, I was basically a computer engineer, and I did a lot of the debugging of some of the problems which came up later when we started doing bigger systems. But I basically, myself and Henry Harold, basically debugged the initial 2 machines, the 910 and 920.
And I might add, you did the 930 too,
Well, I did 930,
because we
which I
didn't
was-
have to do any programming. It was compatible with the...
Right. But
So it was
I resented
engineering.
doing the 930 because the company had sent me to Paris for a computer show with a French company with which we were affiliated. And I had a lot of vacation time because I'd been working 9-10 hours a day for 6 or more days a week. And I called Bob Beck, who was my boss, and said, Bob, I'd like to take a week's vacation and stay here in Paris and have some fun. No, he said, you get back right now. We've got to get the 930 out immediately. And so I had huge resentments with respect to doing the 930.
Was it Intertechnique was the company? Wasn't it?
I don't remember the name
CG.
of that company.
Huh?
CGE.
Who was it?
CGE. CGE.
Oh,
CGE.
Company
General
General.
Electric.
Yeah, that's right.
CAE.
Informatique.
CAE,
CAE.
Company Automatique Electronique.
Yeah, that's right.
I like
That's
your
right.
original name.
I've confused them because we had another agreement with, when we were at Packard Bell, with a different
Intertechnique.
French company. And so I'm not sure which company was which at this point.
They all spoke French, though.
Yes, and I think I was sent because I spoke French gobbledygook.
Good. Let's see. I think I'd like to switch and ask Bob to say a few words, introduce
refute
himself,
what was-
and then we'll get to Max and Art.
My name is Robert Beck, and they've told a very good story already. Max and I, as I recall it, really met at Packard Bell, where my great pleasure was doing the detailed design of the G15, which was an interesting
I was
computer.
at Bendix, right?
Well, could be.
Yeah.
Bendix, yeah.
Yeah, that was at Bendix. That's where Max and I got acquainted. And I was always proud of that G15, but when Max really wanted to start the SDS, I was just delighted to join in. I guess I was the chief engineer, the head engineer for most of the thing.
Co-founder, I'd call you.
But later, I became executive vice president of SDS because I sort of then tried to manage manufacturing and engineering, which was a very hard go, I'll tell you, with this tremendous growth that we had that was really unbelievable.
Okay.
So one of the pleasures I had was going to the New York Stock Exchange and seeing our stock traded across the board at the opening.
Yes. Okay. Good. Art, maybe you could just say, introduce
Yeah,
yourself.
my name's Arthur
and-
Rock. I was in the was and still am in the venture capital business, and one of the ventures I came across was Scientific Data Systems, and we invested in SDS, and I became chairman of the board, and it was my job to arrange the financing and arrange anything to do with the financing, but more important, my job was to keep the company honest. And I guess I was able to accomplish that.
Good.
I might point out, I think that we had, $1 million, but we thought we would needed more than that to begin with. Remember that? And we didn't get it. It was very tough times for venture capital at that time. But we had $1 million, so we really did almost everything that we could on that $1 million.
In a hurry. And as a matter of fact, there was an error. Someone mentioned downstairs that we had shipped the first computer a year after we started.
It was less
And it
than
was actually 9
9
months. We shipped the first 9, 10 out the door.
Yeah, but you shipped boards before then.
Yes. Yeah, that's correct.
You actually shipped boards, what was it, 3 or 4
Oh,
months?
yeah.
That's correct. Don,
Oh, maybe somebody could, you tell a little bit about the story about shipping boards. Did you decide to start out in the board business to have some
We
revenue?
needed revenue.
Yeah.
Okay.
Yeah.
So you did what, I think DEC also did the same thing, started shipping boards for the built computer.
I don't know.
But that's what you did?
Yeah.
And Packard Bell, we had done that also.
Yeah, in those days, there were a lot of people building their own special purpose computers, you would call it today, for special purpose applications. So there was quite a big market for just selling individual logic boards and all the pieces of hardware that goes with it, the frames and the wiring and the power supplies and the whole bit.
And A
so-
to D converters.
Yeah, A to D converters. And so one of SDS's first lines was the circuit cards and the bits and pieces from which we would also, to some extent, build our own computers, but we'd sell them to other people, such as I think the naval base out of Edwards Air Force Base was one of our customers that did that kind of thing. I remember that they had a project for some sort of digital device that would help them with gun positioning on battleships, and that was built out of those circuit cards.
I still have one of those boards encased in plastic on my desk.
Oh, very good.
One of the points was that we went to Silicon Logic in the boards. Almost all of the computers.
Silicon circuitry.
Silicon circuitry.
Yeah.
Almost all of the boards before that were done with germanium. And so we were in a unique position.
We were the first.
Particularly with
We were the
the
first.
military.
We were the first ones to do
Yeah.
that.
We were the first ones to do it.
Yeah. Well, Max, maybe you could, I think everybody knows you, so you don't need to introduce yourself, but could you talk a little bit about your earliest thoughts about doing this? Where did the idea of doing another company, and how much was it formed, what you wanted to do?
Well, the background situation was we were a company that was part of Packard Bell. The man who ran Packard Bell,
This is Packard Bell Electronics rather
Right.
than, we're a subsidiary corporation.
called Packard Bell Computer. And the man who ran Packard Bell was, I don't want to commit,
He's dead.
He's
He's dead. It's all right, Max.
You can say what you really think.
He doesn't want to defame the
Can't
dead.
be sued if he's dead.
No, I don't think so.
But anyhow, he was a little unstable and certainly completely ignorant of computers or computer technology or computer marketing. Or he just had no clue at all, and that presented a problem if we were going to grow and become a big company. To have the man who essentially had the last word being totally ignorant of the subject matter. So, and I'm sure, although I don't remember the detail at the moment, I'm sure it had to do with money, that we didn't feel we were getting the right share because...
I remember the details.
I remember the details.
Go ahead.
What happened was we had an agreement with Packard Bell Electronics. Many of us had shares in Packard Bell Computer Corporation. And there was an agreement with Packard Bell Electronics that when Packard Bell Computer Corporation did 25 million gross, that we would be able to convert our stock into Packard Bell Electronics stock, which was selling at a fairly decent price on the market. And what happened was, when that time came, they stalled and stalled as their price was dropping. And we were all very upset that we were losing money because of their delays. And my recollection is that Max issued an ultimatum that if they didn't do something, he would leave. And the guy said, leave. And that basically was the beginning of Scientific Data Systems.
Let me add something to that. Packard Bell was originally a radio company that morphed into military electronics, and they were enamored with that. Totally enamored with the Atlas missile, if you remember. That building the electronics for the Atlas missile, and they weren't that interested in what we were doing. One thing that Max used to say to us over and over again is that no computer company was successful that had a parent that wasn't in the computer business.
Well, what happened to Packard Bell Electronics actually was that they bid on a very large contract for support and further building more units when someone else had done the original, another company, I don't remember who.
Collins Radio.
Was it Collins?
Yep.
Collins
Had done the design, had all the drawings and so on, and had been outbid by Packard Bell Electronics. And so what happened was they were losing their shirts because Collins was in no hurry to deliver the drawings, and so Packard Bell couldn't produce the equipment, which is why their stock was going down drastically.
Well, that's what created the
All right.
problem.
So that created an environment where you were ready. Art, when did you meet Max first? What was your first contact with him?
My first contact with Max was in early 1961. We were introduced by acquaintance of both of ours, who knew what Max was trying to do and knew what I was trying to do, and introduced us, and we agreed to agree.
Okay. So it was a mutual acquaintance, and you got together and talked about what you were going to go do.
Exactly. And they did it. They did exactly what they said they were going to do.
Is that relatively unique or
It's
more or
very
less
unique.
common?
It's very unique.
I think we probably did more.
Right.
Now, Bob, you had mentioned something that you had some discussions with Max about starting something, and you mentioned something, there even was a loan to sort of get this thing started. Could you
Well,
talk
my
a little bit more about that?
my recollection is that Max was, for some reason, a little short of cash at that time, and I remember lending him $5,000, which is just a personal loan, because he was promoting this new SDS company, and he was short of cash. I talked to him about it today, and he doesn't remember it, but he did pay it back anyhow.
Max had an office at that time.
Pardon?
Max had an office outside he was left the company. And almost all of us were still there, I think all of us,
Yeah.
And Max had an office, what was the guy's name?
Benson Lane, wasn't it?
Benson Lerner, and Benson Lerner.
Oh, Jesus. Crazy Bernard.
Oh, yeah.
Okay.
And he developed the business plan with asking us questions, and he filled in the rest.
Okay. So you all sort of were working with Max on the business plan while you were still,
No, not all of
Not
us.
really, no,
not
I.
really, but
not you.
Not I.
not you.
I was on vacation.
Yes. Okay.
Last vacation, right?
No, it was just sort of questions and answers, mostly.
Did the company get money from Art? Did the company have other sources of funding, or did all of the $1 million come from you?
Oh, no. Leonard
Sperry.
Sperry
And another Sperry.
and his brother
Albert.
put up some money.
Albert.
And another venture capital firm put in some money.
The Sperrys were people who had Sears Roebuck money.
Sears Roebuck.
Ah, so from your Chicago connection.
And then didn't Marv Brody represent some group with me?
Rowdy?
But he was related to them by marriage.
Oh, yeah.
I think there's still a plaque to the Sperrys in the A&E building in El Segundo.
Okay.
He had a Bentley, I remember.
You remember the
Nobody
car?
else had a Bentley around us.
I see. Good. All right. Well, so what happened? What happened next? Did any of you had started to work for the company before Art did the deal?
No,
No, they couldn't afford to pay us.
Okay.
we couldn't afford not to be paid.
Right.
Something.
Yes.
Something.
Okay. So you closed the deal, and
October 1961, we
Okay.
started the company.
was when it happened,
Yes.
when the money came in. And how many people were in the initial crew that showed up to?
I think ultimately there were 11 people, not 11 engineers.
Okay.
But there were a couple of marketing people, Bob Fopiano, Jack Bear.
They didn't start the first day.
Didn't they start the first day?
We had to work, we had stuff to bid. You couldn't sell anything unless you knew what it was, right?
That's true.
Yeah.
But
I know some people who can do that.
Yeah, there are some people that could do that. We didn't think we could.
Who were the original 11?
Cliff Huxford was one of them.
right. And then there were
Emil?
Don, Emil, Henry Harold, myself, Max, Bob. We
Ace
had
Spencer, yeah.
a secretary, Sally somebody.
Sally Field, Sally, not Sally Field. Sally, that couldn't add right.
Right.
That's what I remember.
And I think we had, did we have one draftsman?
I think
Coleman
so.
Smith?
Coleman Smith? Yeah, pretty early on. We also,
And
yeah.
I think also a draftsman who worked for him. And I don't know if that's 11, but ultimately, as soon as we got the design done, we had 2 technicians, which I think that all added up to about 11.
Okay.
But basically, in terms of people doing the design, there was Bob Beck, who was involved in the memory design, and there was Don Cooper, who was involved with the circuit and module design for the computer, and then there were 3 of us who were involved with the design of the actual computers.
And then Jim Neal started somewhere along there.
Later, he came in as the, Smith left.
Yeah,
Oh, no, he was the
He was
manufacturing guy.
manufacturer.
manufacturing.
Right, right. And also, when we had a John Cool, who was the service
Yeah, he's service.
guy,
I remember John.
came a little later.
Yeah.
But this was after there were 11 of us.
Okay. I was going to ask about the memory design because I hadn't heard anybody discuss the memory. Bob, could you tell us a little bit about?
It was our first experience with core memories, and we had to hire girls to thread the wires through them, and we built very simple fiberglass frames for the panels, and it was a very precarious thing getting a core memory to work for the first time because the signals aren't very strong, and it took a lot of sweat getting that darn thing to work.
Well, the story, actually, we had another engineer who was supposed to design, who had experience, presumably, in core memories.
Mm-hmm.
And he started trying to design this thing, and it was a disaster. And so finally, Bob, who is a really good designer, took over. And we were on 15th Street in Santa Monica at the time in this building, and it was essential that we get the memory done.
We had a
because-
prototype done by then.
Yeah, we were, coming up with the computers who were almost done, and we actually had one built and no memory to work. And so Bob chained off an area in the center of what was going to be the manufacturing area, and no one, including
Curious.
Max, I think, but only Bob was allowed to go into that area, and he worked night and day to get that memory working, and finally did.
Okay.
It was a very great story. I like it too.
That was the random number generator thing. That, of course, we found the problem, that there was a problem, and then Bob fixed it.
I see. So you were responsible really for the core memory. Did you
Core-
string your own cores or did you buy core
Well, we
plates?
bought ready-made cores and
Yes.
strung the little fiber wires through them. It's a strange thing. Nobody would do that anymore because it's.
Well, we put them in those boxes that you see, aluminum boxes, and Emil's people, the programmers, would come to test some software, and it was, we didn't have fast enough input equipment for it, and so they would load their programs into this thing, into the memory, say 4K worth of program, and then they'd find a bug. But rather than trying to load it in again, they would take the memory box, unplug it from the computer, and then the next software guy would come up and try to load his software in, and there was no memory in the computer.
We had a lot of little tricks in those days.
This is
that's
left
pretty
over from the Packard Bell days.
That's
when
right.
The memory problem was the major problem to keep the machine running. We couldn't get the magnetostrictive delay line memories in any quantity. And Emil, who was head of software, and I worked for him at the time, finally fought to get the programming department issued 4 working memory modules.
And the marketing people couldn't take it away from
They
us.
couldn't put them in machines to ship them, and us programmers would get a module or 2 and go to a machine to debug software, and we'd plug them in, and we'd run our software. When we got done, we'd take the software department's modules out and bring them back.
Well, those delay lines we bought from Ferranti. And they were not building them so they would work. And finally, Don was sent to the East Coast. For how long did you spend
I
there?
spent the winter of 1960 in Long Island.
cold
one of the
winter.
worst-
At
one of
the
worst
Ferranti
blizzards they had
factory,
in centuries.
because they would ship us stuff that wouldn't work. So Don went there to screen it ahead of time and reject anything that wouldn't work before we got it. So, that turned out to be a small disaster.
Yeah.
The computer was sort of an odd computer anyway.
The story that goes with that, and I told it once, but we went to NASA, and we went to a motel in Huntsville, and Werner von Braun came to see the machine, and the PB250, and there was a little demonstration. And he stood up, and he was talking to his people. He said, "We have to get a lot of these machines like that," and he zapped it,
Electrostatic charge.
electrostatic charge from the floor, from the carpeting, and the machine died right there. But he didn't even know it. Max, do you remember that story? It's true.
It's a good story.
That is a good story.
It's true. And he walked out, and we did get a lot of business from them.
That was Packard Bell. Then
That was Peckerville.
Then with SDS, we also went after NASA in Huntsville.
That's right.
We sure did.
I went and Max went, and we had built a power fail-safe system into that computer. And unfortunately, there was a logic bug in it, so that 1 out of maybe 20 times, or even fewer, maybe 1 out of 10, it wouldn't work because of this bug that was in it. So we go there, and they're wheeling this computer around on a forklift to different locations at Redstone Arsenal. And Max is demoing it, turning it on and off, and I'm just, in a state saying,
When is it going to happen?
Don't do it again.
When is it going to happen?
And for that whole trip, it worked every time without fail. But when we got back, I got a machine and an oscilloscope. It was very difficult to find because when you turn the power on is when it would happen. And there was a fleeting instant in there, perhaps a half a millisecond during this multi-second process. And I finally found it, after wearing out, I think, 3 power switches and fixed it, and but he had me terrified at Redstone.
I had the software that ran the demonstration that the power thing was interrupting.
Right.
And
Oh,
I had a
Take care,
guy who was
Emil.
working for
Send
me
me
had
an
written
email.
part of it.
Thanks.
Take care, Eamon. Nice to see you again.
Yeah. Thank you, Emil. Thank you. Yes.
When we got to Huntsville and we were trying to get it all working, the software didn't work right. So I'm busily trying to fix this code that somebody else had written. And Jack accused me of talking to the machine because I'm ignoring everybody else and talking to the machine or myself trying to fix the software.
I think it was your language that upset me.
And we finally had to stop pulling the plug out, which was, we thought, a much more dramatic indication of, it could really handle a power failure. Because when you yank the plug out, there's this big arc that would occur. And all the engineers were concerned that would disturb other things. I'm only concerned whether my software will work.
Right.
And whether it'll start back up again. And I built in a big long delay because the typewriter, a stretch Selectric typewriter.
That was your main I.O.
That was the main I.O. It would be typing things, and then when the power failed, it would stop typing. But unfortunately, all that mechanical motion might not stop in a very good place. So I would give it a long time after the power came back on to settle back into some known state before it would start typing again.
It would type, a power failure has occurred.
Yeah, something like that. But the long delay meant that we spent a lot of time going, I hope it starts this time.
Oh, that's very good. maybe I'd go back to Art and talk about what sorts of problems in the first year that you saw as, at your level, thinking about the overall company and its finances and sort of what was going on.
Well, the only problem that I had to face was how to finance the company. And I don't remember, but we probably had additional stock issues or debenture issues. Do you remember, Max? I don't.
No.
But we just had to,
Okay, so everything else,
I've got another hour.
He's on Arizona time.
I'm on Arizona time.
it's back.
wonderful. Excuse me. Good. Could somebody comment on your where the decision to make this a silicon transistor machine came from?
I would think Max must have made it.
Yeah. Well, we were at a stage in the technology where it wasn't clear. There were people understood that we were giving up vacuum tubes, but whether we would go then to germanium or to silicon transistors hadn't been clarified or decided upon. So always wanting a marketing edge, we decided that we would go to silicon transistors. Looking back, I don't think was a very good decision. It gave us, for a while, a talking point, but it had problems, and eventually we gave it up. We went to germanium, but for a while it was. Isn't that true?
No.
No.
Did we ever? We never went back.
We solved
Never
all
went
the
back.
solved all the
We
problems.
solved all the problems and stuck with the silicon. always.
Okay. Well,
The manufacturers started making good enough
It
silicon
was
products.
Fairchild was involved with that,
Yeah.
wasn't it?
Yeah.
yeah.
It took a lot of work to get good enough silicon transistors. They weren't comparable to
And the
germanium.
diodes as well.
Yeah.
Yeah.
So
This is pre-Intel days in
Yeah,
Fairchild.
this was
of course.
Fairchild.
When the Intel
Yeah.
people were there.
So
In those days, I made many trips up here to Mountain View to Fairchild to work with them on issues regarding quality and getting the right product for what I need.
But just this little discussion, you can see that it involved effort and difficulties, and we were just
In fact, it was a brilliant decision of yours.
yeah, it works out.
it was a handful of guys in a garage in a back street, and
Money was running out, too.
we didn't need further difficulties to have to handle. On the other hand, it always struck me as being a very good marketing ploy, because there are advantages to silicon, temperature particularly.
Certainly, the temperature range of the
Yes,
machines
yeah,
was
right.
And many of our
very attractive to
Yes,
people who
yes,
were in
yes.
Who were building systems.
in industrial environments.
Right.
Yes.
So we made the decision to go to the silicon, but it was dicey. It was not. It was not an obvious correct decision. But
I might point out that our cycle time on the computers were slower than we could if we were risky. We wanted in a six microsecond cycle time that we had on the computer.
God, I don't remember.
But it was conservative. We wanted reliability over speed, and we made up for the lack of the speed by the design.
Okay.
There was a rather key design point that I think the engineers should talk to. They had all come from Packard Bell, and that was a serial machine, the rotating memory and the rotating registers, and we now had Core. They came up with a rather clever design where the registers in the 910 and 920 were solid state rotating memory. And nobody ever knew it that programmed it, except that they would ask an add or a load instruction only took 2 cycles, one for the instruction, one for the execution, but a store took 3.
It's true.
That's right.
And we
I'd
would
forgotten that.
we would say, well, it's just the way we do the system.
That's those stupid guys over there and the other.
And I don't think very many customers ever realized that the logic was serial, even though the memory was parallel. Because everybody who built parallel memory machines built parallel machines. We kept the cost down by doing serial.
That's right, all the
Logic.
adders and so on were serial adders rather than parallel.
So it saves a
So-
lot of components.
That's right.
Yeah.
Yeah.
Right.
Diode here and a diode there, you got some real money.
And a lower failure rate.
And a low failure rate.
Right.
That's when the essence of logic design, as I learned taking the course from Monty Pfister, was the minimization of flip-flops.
That's right.
Okay. Good.
Was it he who designed that one flip-flop machine? Someone did.
Well, tell me, are there, tell me about some other difficulties or that you had to overcome in getting the machine to the point where you could ship it to a customer.
How many years ago is this?
Well, it's 1962, 62, it'd
Really
be
45.
45 years.
45 years ago, so.
Yeah. Okay.
Well, my
Well,
recollection is we had-
Max used to go on trips and see customers. And when he'd come back, that's when we'd ask him for something, if you needed something, because he was way up high. And he would call us in, we got to do this, we got to do that, whenever he'd come back. So he would get a lot of new ideas from the customers. And that's good. There's nothing wrong with that. But when he was away and things were nice and calm, we just worked. When he'd come back, bam!
But we figured out pretty quickly that unless we could give better performance than IBM by a factor of 3 to 4, it wasn't worth talking to the customer.
And that's, that's logical, that makes sense.
And that's because the customer.
Well,
would take-
IBM,
would say
I
that-
mean,
yeah, they
it's a
wouldn't
safe
want to
bet.
take a risk with
Yeah.
new company.
I can remember, we had very little money for software. And so we needed a Fortran compiler, for example. And we didn't, we got bids. I can remember computer usage. What was the name of the guy that died? The famous founder of, wasn't that computer usage? It was, maybe it was. Max had a friend that was a computer usage. Max, you had a friend at computer usage, didn't you? Back east. And they bid on it. And it was computer sciences.
Uh-huh.
The founder of computer sciences, and they bid on it. Remember, I don't know if you remember this, but he came up in a Rolls Royce
No.
in 15th Street to deliver the bid.
By the way, he came up with a Rolls Royce, and our location on 15th Street was immediately adjacent to a automobile junkyard.
Don't you remember? But don't you remember the Rolls Royce?
Vaguely, yeah.
Yeah. And he delivered the presentation. It was $95,000 he wanted for it, and I think it was the computer usage wanted $105,000 because we didn't have anything like that. And Digitech, huh? $25,000, with a very unique way of doing a Fortran compiler. Turned out to be the best one in the business, the $25,000. But we barely had enough money to pay that.
So cash was very tight in the
Yes.
in the early days.
And that worked. The software, we got very good kudos on the software in the early days, and we started a users group. We listened to them, and we responded, and we had everything that we needed at a very low price.
You can see that the company was very professional. The people were very smart, and very smart in the way that you run this complex organization that's a computer company. It was very, it wasn't just intelligence, but it was also a great deal of deep experience.
That's what made it all so much fun.
Yeah.
And a lack of politics, too. I mean,
Yeah.
there were no agendas.
No.
There were no agendas. We just had to survive.
Yeah.
Yeah. So everybody
Yeah.
pitched in and did the best,
Yeah.
helped everybody else.
Yeah.
Oh, yeah.
Good. Well, I think we've just been joined by one more
Oh,
guest.
just keep going. I'll listen and
Well,
I'll contribute when I can.
would you be willing to just introduce yourself to the
You better
to
sign
the,
the release
to the
first.
camera and
Sign the release first, Bob.
He signed up.
and just say a few words about how you became associated with
No, well, he was known
SDS
as
and
But he's poor. Poor about that.
what you did
They
initially.
switched rules.
Okay, my name is Bob Adams. There were two Bob Adamses. I'm Robert P. Adams. I first met Max, I think, at on Ann Arbor Street. Is that right?
Arbor Vitae.
Arbor Vitae Street.
Yeah.
When we were working on hooking an 1103A computer to an electronic associate computer, an analog computer, to a digital computer. And we talked, and nothing really came of that, but then parted. But impressed? Yes, I was impressed. And when Max and Bob were at Packard Bell and then moved on to start a new company, I couldn't have been, I was itching to join that company and was invited and started there. My job initially was in what we call the systems division, and the systems division was basically those who took the computers made by SDS and added content, software or hardware, to do a specific job. An example of that is one of our customers was JPL, and JPL was doing work with what is known as the Deep Space Network.
Goldstone.
At Goldstone. The first machine went into Goldstone, and it was a computer with lots of embellishments. JPL and NASA liked that machine so much that they put our system into all of the sites of the Deep Space Network. Help me, I believe there were 7. Is that correct?
What was that you
There were
said?
7 sites in the in
Yeah.
the Deep Space Network.
Yes.
Deep Space Network for years were spaced around the Earth to
Ascension
monitor
Island, Australia, there was one in Australia.
Canberra.
All around the world, to handle satellites.
Yeah, the idea was around the world so that any time of day and night you can see an object in space. And we did many other systems.
Bob, I might point out something. The Ascension Island machine died a natural death somewhere because the diodes and all fell off the cards. Do you remember that, Barb?
I remember nothing.
The weather was awful there for computers. Do you remember that?
No,
They fell off the cart, so they had to replace the whole thing.
What a story.
That's pretty unusual.
I would also mention in the hardware area, when integrated circuits came along, no one had built integrated circuits for used in digital computers. And SDS designed a flip-flop package, 2 flip-flops I might add, where today machines have hundreds of thousands of flip-flops. And this machine, this design from our company was mechanized by Signetics here in Silicon Valley in 1 month, and it worked, and it went into a TO5 can and was used thereafter. To my knowledge, this is the first use of integrated digital memory circuits in the world. Now, you should check that statement. But,
I can confirm that because I wrote an article about that development because I was the circuit designer working with Signetics. I think also Fairchild, but I think Signetics got the production contract. And it's in, I've got a copy at home, it's in Solid States magazine of that era.
But that was the 925, right?
Yeah, what machine was that used in?
I can't remember what machine it went
because
into.
we couldn't fit everything we had in conventional circuitry in the box.
In
So
the
it was a
package
last minute necessity.
to compress. Okay. Could,
So I have a copy of that magazine, so I can send you
oh,
the
we
magazine.
would love to have that
Yeah,
for our SDS collection.
yeah. Okay.
That'd be wonderful. Thank you.
Okay, round I'll end up very quickly. At that point, I was appointed vice president in charge of engineering, development engineering, and I think it was really simply that I was the only one that was a spare. Such people as Jack and Emil and Don Cooper were the heart of the company, building it together. And there's this guy who maybe knew a little bit more business than the others, but became in charge of that department.
Okay, good. I'd like to go back and hear whether anybody remembers who the first customers were
Motorola.
for the
For a transistor production
It
line.
was a computer to put in their transistor production line. So the transistors are coming down the line, and the computer had to test the transistor. If it was really good, then it went to the government. So they'd open a little chute and it would fall down into the government box. And if it was really bad, it would go somewhere else. And there were other places. But anyway, they needed that computer in their line to test them and sort them.
Yeah, real time.
Real time.
It was funny because we had, I think, an error in the memories of those machines, which we retrofitted throughout, every machine. And Motorola would not let us touch that machine, I think, for 2 years. And it had this error in the machine. But they just ran it night and day, 24 hours, 7.
and it didn't
And
affect the software they
we were
running.
terrified, but ultimately, we upgraded it.
Well, Tom Marshall did the programming on that, and it was the first time he'd done anything like for us and that. And he was so good that they almost wouldn't let him go, and we kept saying, you've got it done enough. We they should pay us some more money for what you're doing, and he wouldn't leave it until he got it super right.
Good. Was this a 910 or a 920?
It was a 910.
910.
It was a minimum machine, yeah.
Wow, okay.
I think with 4K memory.
With 4K memory.
All right.
Oh, that's when we upgraded this. They needed to make it 8K. And so we just switched the memory things and gave them an upgraded one. So that
You
they
slipped
would-
the upgrade in on.
Yeah, right.
Very good.
I think the JPL machine must have been one of the early ones also, which was
Westmoreland.
Paul Westmoreland.
Paul Westmoreland.
Which was a 910 and a 920. And the only difference between the two machines was that the 910 had some modules left out of that. It was pre-wired and it could be either machine.
Close,
but no cigar.
Close, but no cigar. But Paul Westmoreland
They were
became our
different
big,
machines.
became our
The
big
910 and
salesman.
920 were actually different machines with different logic designs.
Okay.
They were not just, plugging modules in. The only time we did something like that was on a computer called the 92,
Yes.
That's right.
which was a little one. And there, that machine basically was the first machine to be designed by the marketing people. And we all in engineering hated it. And so what they wanted to do is they wanted to have two versions of it, one of which had an additional set of commands in the structure. And so what we did, we designed it with everything in it, and then we disabled part of it. And
Sold it cheaper.
the hilarious part was that the machine itself was wired with white wire, and the disabling part was wired in black wire. And one of the guys who worked for me had the job of going out and upgrading it. And he would get out with a pair of wire cutters.
Just cut the black wires.
And he would cut all the black wires out and say, "That'll be $5,000, please." He came back and he said, "I can't keep doing this. I can't face these customers."
Oh, that's a wonderful story.
We gave the upgrade to Shell Development to compensate for all the problems we had in getting the 920s that we had installed in Houston to work. And the guy that was in charge was a very sharp technical person, but his management was off negotiating with us for compensation for all of this effort that we had put in and had not gotten the machine to work to their satisfaction. And I think McGurk was negotiating our side. And they had bought some 92s to go on shipboard for seismic
Seismic work.
surveys, and they were collecting data on shipboard. So McGurk gave them the extra instructions, the multiply divide instructions for free. And the
Snip, snip, snip.
the technical
Very
manager on
generous.
their end knew what the difference was. He was technical enough to have figured it out. And he went through the roof, but his management had already agreed that that was their compensation.
Oh. Very good. Very good. Tell me about some more of the early systems that you shipped. Any more stories? Good stories about early installations?
Yeah, we
Those
had.
are usually the ones that sometimes are a little shaky.
Yeah. They, in Huntsville, or maybe it was Houston, they in checking out the missiles at that time, their vehicles.
I think it was Huntsville.
Was it Huntsville? Okay.
Yeah, it was the
was
main
called-
missile system.
It was called the Digital Events Evaluator. Our machine would sit and listen to events as inputs were changed and would predict faults in the space vehicles. And if it passed through our test station, it would then move on as a operating missile.
Okay. Good. Was that
So-
enough?
And that machine, talking about Terra, John Moser designed that machine. And John was going to Hawaii, so I inherited it. And I went down there to install it, and it had a flaw. And the flaw happened very infrequently, but it definitely was there. And if the machine ran at a certain speed, it practically never made an error. And we didn't know what the problem was. And so we ran it in that mode and in terror and came home. And the machine, I'm told by my brother worked there. My brother went around to ask. As far as I know, our digital events evaluator never made a mistake.
And you never had.
And
to
I
go
was still
and
in
fix the
terror.
problem,
Right.
whatever it was.
No.
Now, you said that somebody had designed the machine. Was this a
system.
special system?
The system.
This is a
Custom
system where the
We
front end.
made a lot of systems in which the computer was the heart, and then there was a bunch of additional logic to interface between the computer itself and whatever the external system was.
Okay, and the customer's equipment.
Right.
And Max made the suggestion, the decision that the costs were so small in upgrading a machine into a systems of this type. Why should we charge money for it? And so we, Max instituted a program where we delivered systems at the price of manufactured hardware. And we made a great deal of money that way.
As long as the customer accepted them on our premises.
So you didn't have to go there.
That was about a third of our business at that time, I think, the systems business.
In SDS nomenclature, systems business meant custom system. We
Yeah.
were building computer systems, but when we said systems, it meant a custom system for the customer with computer and other things.
Right, and that's about a third of the business.
Yeah.
All right.
Another computer that was delivered was, someone correct me here who knows astronomy, one of our planets goes the wrong way, and this had never been confirmed, proven by experiment that this was the case. This again was JPL. JPL and one scientist at JPL who used our machine to confirm the fact that this one planet went the wrong way.
OGO.
Beg your pardon?
OGO.
OGO.
Pogo.
OGO.
Oh, gee.
Orbital Geophysical Observatory.
Okay,
Could be it.
could be, but that was an early system.
All right.
Yeah, I know, but I think there was a
Okay.
system like that too.
You're testing our memory, you know, that's a long time ago.
Well, you
particularly on-
you are doing very well.
On individual systems,
Yes.
no way.
All right.
Something came up.
We did some brain research center work for UCLA.
That was in 930.
Oregon, University of Oregon, I think. You know, in the laboratories, you know, experimenting with primates. And they take the
That was
crane
filming.
of the primate off and wire it up and doing brain research.
Oregon Primate Institute.
Oregon Primate Institute, that's what it was. And,
Very interesting.
and so that was
That's
another
partly-
step forward, you know. You had to have a very a fast machine that could gather that data rather rapidly and make any sense of it.
But those were 930s, I believe.
Yeah, I think that might have been 930s by that time.
Yeah, we put a lot of 920s onto the deep space tracking radio telescopes that NASA put around the world to track the orbital and deep space missions that they were beginning at that time. There were 11 of them, I think, in the initial configuration that NASA had.
That's the one I was talking about at Ascension Island where the components fell off the cards because of the the weather, terrible.
They had one at Goldstone, which is in the
Lots
high.
of, I used to go, when I was depressed, I'd like to go out to Goldstone and see all the SDS machines that were all over the place. If you closed your eyes and walked in a straight line, you'd hit one, for sure.
Of course, the little handouts they gave you said, don't close your eyes and walk in a straight direction, look down for scorpions.
Yeah, right.
Perhaps you've gone through this already. Stop me. You have, but in my view, the real success of the SDS machine was based on machines designed earlier, primarily by Bob Beck, and the component that Bob designed was a very fast flip-flop. Bob poured hours and hours into that machine, into the flip-flop. The reason this was so important, it would not be today, the reason that was so important is the cost of our machine was hardware dear. That is, the components who went into such machines were the key cost element. And other people, such as Digital Equipment, DEC, were true parallel machines. That is, to add a number, you had a parallel adder. In Bob's machine, with this super fast flip-flop, we could do it serially. That is, the bits would pass by the flip-flop and some logic, not much. You would add successively, bit by bit, and then you would come up with a result, which is, if you like, is a parallel word, which could then pass on to do the work of the rest of the computer. So if you're talking 24 bits, it means that we have about 1/20th of the hardware that our competitors had. Hence, our ability to sell a machine at a lower price and make a handsome profit, all based on
That's
a
great.
super fast flip-flop. Is that pretty close?
I think I like that, yeah.
And reliability was hard. Reliability was hard.
Yeah, oh, right.
Now, was I heard you talk about a serial, that the registers were serial,
Processing.
were shift registers. Were they also dynamic, so you didn't have to have a flip-flop at each bit?
We had no dynamic circuitry.
No dynamic circuitry.
I don't think dynamic memories were available at that time.
Right.
Is that what you mean by?
I could conceive of Bob designing a circuit that is
No.
one transistor per bit.
Oh, no.
No, okay. It was just a serial memory with these
Right.
very fast flip-flops. Okay.
Huge difference. I emphasize a huge difference in cost that was based on dear costing hardware.
Right.
Very interesting. Good. Now, who were your principal competitors during this period?
PDP-1. PDP-1 from DEC.
PDP-1.
And control data and to some extent too.
Yeah, control data, again, talking hardware, control data.
160, 160A, I remember the numbers. But they really, both the PDP-1 and control data machines were not built by anybody that really understood the real-time world. They had to add a lot of stuff to make them work in that environment, and that made them non-competitive lots of times.
Yeah, furthermore, the machine had an interrupt structure which didn't work. Okay, strong words. They had an interrupt structure that didn't work. And we logically, I guess Jack, are you involved in this?
Yeah,
Built
I did
a
those
true
interrupt
interrupt
things.
for a machine, absolutely necessary for a
That
real-time
was
machine.
a massive difference. They were using serial logic. You know, they would say an interrupt occurred, and then the computer would have to say, what happened? And look around for something that happened. But ours, whenever the external interrupt occurred, it went to a location.
A memory location.
When
memory
there's
location.
Where
specific
there was a
location
subroutine
where
to
the
handle that
subroutine was.
specific.
And
interrupt.
it bounced right into what it was supposed to do.
Furthermore, the early machines, besides ours, in particular DEC, particularly DEC, using one's complement arithmetic, whereas we used two's complement arithmetic. And either one works, but it's much, much easier to use true two's complement. Again, simplifying Bob's serial concepts.
Okay. Could somebody offer why that is true?
Why it was true, or
Why is one complement, in your machine would have been more difficult, or?
I guess
been
I
a
need
detriment?
help there.
I hope somebody here can answer.
Okay.
Sorry.
Good.
Probably,
But you figured it out, and that's what you did. Good.
In today's logic, that doesn't make any sense, but,
Yeah.
because 45 years ago, it did.
Good.
When we talk about real-time systems and how successful we were, by the time we got to doing the architecture for Sigma, and that gets recognized a lot for including time-sharing capability and the memory map for relocating programs. But underlying all of that was a continuing improvement in our capabilities to do real-time. I spent lots of time talking to people in the systems group about the problems they were having in building special systems. So when we did the architecture, we made improvements on the interrupt system, which Jack had developed so
No,
well.
but you came up with the design really for those, because you told me what you needed.
Yeah,
And I really designed the modules.
But I was building on the capability that was in the 9 series.
Mhm.
And, he had educated me about how a priority interrupt system would work. And we just enhanced it. We included the abilities to enable or disable specific interrupts if they weren't important. And the other thing that was always coming up by the system designers was the speed with which you could acquire information. How fast was the interface? So we made an effort to make sure that we had interfaces for as fast as you wanted to go. We had 1-bit interfaces, we had 1-word interfaces, we had the I/O channels, serial and parallel, and if you needed it, you could get on the memory bus. We gave that interface as a capability. You could build a system that just tapped to the memory bus. And the other thing we did in Sigma was made multiple memory buses so that the memory modules could be accessed from several different processors.
No, I don't think the competition ever caught up to any of those.
No, as a
What
matter of,
happened was that the computer got so fast it didn't make any difference. Eventually.
Okay.
Now, computers, you mentioned timeshare. People, again, computers were dear. Computers cost a lot of money. And so it became to the advantage of many business customers to use the computation power of the computer for a while, and then it'd be turned over to another person, and then another person, etc. The early machines who built timeshare machines did it by swapping memory. And by swapping memory, I mean if a user was on there that had his environment, in order for it to go to the next user, you would dump what was in the first memory, replace it with the second user's environment, and then proceed to compute, and to the third user, etc. Our machines, when we built a time-shared machine, was built according to what is known as Project Mac specification, which was the MIT environment, where you did not have to swap out the memory at all. You merely said, go to user 2, and it would go to user 2, and as long as the memory was big enough, the two could be intermingled, and through the architecture of Project Mac, the motion was instantaneous. All machines are built that way these days, as far as I know. But ours was the first, and we had a comfortable market there for at least a year, which is an eternity in the business world.
Actually, Bob, the architecture of the Sigma 7 had the memory map, which was the basis for that switching, before the Project Mac had described it. And in fact, Jerry Mendelson and I have a patent on a memory map, which is the thing that allows relocation or virtual memory, as we call it now. We never actually defended that patent, but I have a copy. It was issued.
Great.
I remember you presented that at the Brentwood Country Mart. Remember that? We had lunch there, and you presented that whole memory map idea.
Very good. Now, what year was this?
This was when we were doing the architecture, so that started in '64. We finished the architecture by the end of '65 because we built the machine, which the Sigma 7 was delivered in '66 as promised, I think December 33rd of 1966.
33rd, yeah.
But it was done in that, probably in late '64, early '65.
Now, did all of you work on the Sigma series? I'm
Yes.
sort of interested in how long the original team stayed together.
Oh, we were all
I
there.
was
Yeah.
still there when we did Sigma 7.
That is certainly not all the people.
All there was Jonas. That's your position.
I was not.
So I stayed an extra 6 months beyond their contract because Arnie Spielberg.
That was 66.
Right. I left in 1966,
So did I.
Okay.
as did Emil.
Henry,
We had 4.5-year employment contracts.
4.5 years.
Well, that was an interesting story, which goes, maybe,
we didn't have anything to do with it.
maybe I shouldn't go into that, but for an interesting, it was initially 5, and then for various reasons and negotiations, it became 4.5.
Okay.
And so after that period, I wanted to leave, and but that Arnold Spielberg, Steven's father,
Yes.
worked for the company
Steven's
at that
father
point.
worked.
Yeah, he wasn't known as that then, but he asked me to stay on another 6 months, which I did.
Stephen was Arnold's son at that time.
Yes.
And Arnold used to complain endlessly about Stephen. That kid wants a new camera. I just got him a new camera. He wants one. This one's going to cost $4,000. I just bought him one for $2,000.
I too have a
What is
Spielberg.
wrong with that kid?
I do have a Spielberg story. Arnold took over my job when I left in '68, and Arnold was from GE, marvelous engineer. And for a 1-month period, we overlapped where I tried to bring him up to speed. And we would get together every morning to talk about what would happen that day. Well, Arnold one day came into my office, plopped himself into a chair, and said, "He did it again." And I said, "Arnold, who did what again?" He said, "That son of mine." He said, "He once again climbed over the fence of 20th Century Fox, only because he skipped school, only so he could go watch people make movies. And they threw him out and called me, and I had to go pick him up." I didn't know for years who this kid was until long after SDS, and his name was Stephen.
That's a good story, yes. So the two of you left in, now,
66,
in 66?
66.
having started in 61.
Okay. Now, what did you,
I wanted to run a company.
okay,
I wanted to retire.
all right, those, both perfectly good motivations.
Yeah.
But then I designed a desktop computer, and, well, first I built a Sigma 2 in my den from parts they were going to scrap. You know, and I knew all the guys in the department that was handling this surplus. You know, they were going to sell it for the gold plating and
Yes.
so on. And so I got all these parts and built it, checked it out, made it work, and then I decided I needed a disk drive. And one of the old SDS guys was Ben Wang, who had worked on the magnetic tapes at SDS, and had started his own company called Wangco, later purchased by PerkinElmer. And I got a surplus disk drive from him and designed an interface for it for the Sigma 2. So I had a magnetic tape, a disk drive, paper tape, punch and reader, and all of this in my den. I had to redesign the whole power supply arrangement, as I was discussing with Don, because it was designed for 243 phase, which I didn't happen to have in my house. And when I contacted the power company, the price was going to be more than anything you can imagine. And so I had to redesign the power supply for it, which I did, and finally got it working.
Oh, that's
But it
great.
took up most of the den.
I'll bet it did. What did you use it? Did you,
I used it to play around, and then also I designed in the early 70s, a desktop computer using a microprocessor. And we ultimately started a company building these things, and but the market wasn't ready for it yet. But it was an interesting little computer which had
yeah, what microprocessor did you use?
we used, unfortunately, the 6502, you know, which, in my from my point of view as a logic designer, was a much better computer than the Intel x86, at that time the 8086 computer, which had all these weird, I don't know who designed that initially, but they were not computer designers who designed it. Whereas
You're actually correct.
yeah, the 6502 looked like it was designed by someone who knew how a computer worked. And was much faster, in fact, in many operations.
Okay.
And do you want to know why IBM selected the 8086?
Why?
Because somebody else at IBM had already selected the 68,000, and IBM's rules said that if you
can't
were
have the
going to
same
use
one,
a component that somebody else was buying, you had to coordinate your buy through them. And that PC division didn't want to have to deal with anybody else in the IBM bureaucracy, so the only other alternative was the 8086.
Interesting.
Interesting. Good. And so, Donald, how long did you?
I stayed until 1967,
All right.
and at that time, the company had grown to be quite big. I think it was 2,000 or 3,000 employees, and becoming, more bureaucratic and impersonal. And
Right. The favorite expression from Bob and Max was always, "We're a big company now, and we can't do things that way anymore."
Okay.
So I had an offer from another company in the peripheral business, Data Products, and at that time they were a quite successful company making impact line printers, high-speed line printers, and disk drives. I haven't been to see if you have a sample of theirs, but I think theirs was one of the pioneers certainly in the field. That time the discs that they used from memory were like 3 feet diameter. They were huge. I remember that one of the things about them was that you had to be careful to run them up to speed before you ran the heads in, because at rest the edges of the disc drooped down,
Yeah.
which of course wouldn't do. So you had to wait till centrifugal force made them flat before you could start really using them. And then the other thing was, of course, being They were fairly thick too, so there was a big mass spinning there, and so when you turned it off, you had to wait quite a while before it came to rest. So I went there because they were looking for a manager of their component standardization.
I stayed, and in 1966, we began an interesting project with the French computer company. This was the one that we had been doing business with. They were our licensee. And they wanted to build a big computer.
Sigma 9.
Well, actually, their problem was that there was no all-French computer companies left except this little one, because de Gaulle had let GE buy into Boule, and so it was no longer all French, and the United States wouldn't sell them CDC supercomputers at the time, and they wanted it for their own nuclear research. So the French government started to fund CAE to build a French computer that was be big enough to do significant research. And they came to us for help. Max negotiated an agreement, and somehow he decided that I should run this relationship. And the first problem was doing the architecture. And we told them we didn't really want to build a supercomputer, but we were interested in building a multiprocessor that could do lots of things. So we went to work jointly on an architecture for a multiprocessor, which was being toyed with by a number of companies at the time, but there wasn't an agreed upon way to do a multiprocessor. Many people thought you had one processor that was in charge and it allocated things to others. And my proposal was what I called an anonymous processor multiprocessor. And the whole idea behind it, it's a matter of getting your mind around a different way of looking at things, is that processors, CPUs, are very strong but dumb. They have to ask the memory for everything to do. So the memory is the smart element. The processors always ask it. So if you think about that as the starting arrangement, you can build multiple processors, the memory, same program, feeding all of them. And we built up the whole architecture around that concept. And the French built it.
Well, they never got it running.
No,
They had Henry Harold, who was one of our co-designers, consulted for that French company. And he used to tell me about what would happen. And what they had was different people designing different portions of the machine. And the interfaces between these two portions were not compatible. And so Henry would go to one.
That's very French.
Very French. And he would say, this is not going to work with so-and-so's part of this machine. You have to change this interface. Why can't he change his? And so Henry would go to the other guy, and he'd say, oh no, not me. He should change his. And so I don't think they ever really got it together to get the total design done.
Well, we came back after that, and by that time we decided we needed another machine. So we used a lot of the concepts, although we simplified some things to build the Sigma 9, which was also a multiprocessor, although we made some compromises in order to make it more implementable, but it was successful as a multiprocessor. A lot of installations were multiprocessing and doing all that time sharing.
Okay, good. I just want to get, I know this was supposed to be about just the very early machines, but could the panel comment on the genesis of the idea to build the Sigma line of machines after the 900 series, the 24-bit machines? Where did that come from?
It came from a lot of places, but I remember a story.
The company had to build a bigger machine than the last one, okay? And do you build on the old, or do you create new? And that's really what it was.
Yeah.
You had to start somewhere. with the
Okay.
new architecture.
Is there a customer demanding it?
No.
I think
They just
the,
want, you couldn't sell them a new machine unless you had something better, right? So they didn't come around to ask you, unless you had something better, you'd go see them.
I think correct me, I think the impotence was the need for time sharing, true time sharing. Our earlier machines did not have it. Other people out there were doing it the wrong way, we've talked before. Architecture had advanced to the point that true time-sharing machines were possible, hence the Sigma series.
I think from a hardware standpoint, we were encountering limitations on the 900 series, and I think from memory, a couple of things I think were driving the hardware design were, one, the advent of integrated circuits. I mean, they were becoming more and more available with more complex functionality. And the other thing was the whole back panel design. As you increase clock speeds, from memory, it seems like 10 megahertz was really a critical point for us. And I remember we went through all kinds of gyrations to be able to distribute the clock signals to the different modules that needed it. The conventional wiring wouldn't work. There was too much reflections on the line, too much crosstalk to the signal lines, and
Too
so
much
forth.
delay through the length of the wire.
Yeah, that's right.
Yeah, and so there were a number of issues there that had to be resolved, and we did come up with a solution and to that, but it was required a whole new kind of architecture. And I think also, probably Bob or somebody could address this, but we also needed to pack more circuits into a given physical space in order to get the total complexity of circuitry needed to implement a bigger machine. You just can't keep growing a machine bigger and bigger. You need bigger and bigger rooms.
The bottom line, though, in a company like SDS was at the time, the product planning people were available for something else. The computer design team was available for something else. The circuitry people was available, and the software people were available too. So you need that availability to do something dramatic.
Okay.
And if you have a lot of painters and you want to paint a house, I mean, you got to put them to work some kind of way so you don't lose it. I think there was a lot of that too.
That you just needed to have a new challenge
Yeah.
for this team.
Well, I think it's the competition is getting a little.
Well,
Demand.
that would do it too.
Competition was there too.
We had the first indication of time sharing when we were doing the 9300, which was the last machine of the 9 series, and Max came back from one of his trips talking to some professor.
Yeah. I remember that.
And he came back and talked to us about multiple people using the machine at the same time. And I know Jack's in the room, I know Henry Harold was in the room, we looked at him like, where do you get these ideas? And we finished that machine. But then when we started thinking about what we were going to do next, and this started shortly after IBM announced the 360. April 1964, they announced the 360. July 24th, 1964, we had an off-site first 5-year planning meeting where we were going to plan where we were going. I remember the date because it was my wife's birthday.
It's also my
It turns
birthday.
out to be Max's birthday.
And my daughter's birthday.
And we talked about where we were going next. And Max had just hired Jerry Mendelson to head product planning, which was a misnomer. It was really the architecture group. That's what product planning was concerned with. And we took all these inputs, all these requirements. What was IBM doing? How it was going to change the industry? What were demands from our customers in real time? What was happening with this whole time-sharing phenomenon? And there were a number of experimental machines by then, built by SDC. Other universities had experimental time-sharing machines. And we went and talked to a lot of them. We talked to our systems designers about what was required. We looked at the interrupt requirements, and over the next year or so, we did the architecture for what became the Sigma 7.
It had a lot of new ideas in it. And, then I looked back at all my engineering colleagues here to make all this stuff work, which they did. It took a little longer to make the software work, surprise. But we did get a machine out that had all kinds of capabilities. And we put a lot of emphasis, I remember, in the interrupt system. IBM had very long instructions. They could do decimal instructions, they could do string instructions, and these things were not interruptible in a normal course of events. And we didn't know if we absolutely had to do some of those things, but we did them because we were going to try and make a machine that could be used in a lot of different environments, business environments as well as our real-time scientific. Jerry Mendelson and I gave a paper at a computer conference where Gene Amdahl was the moderator for the panel. And we put a lot of emphasis on how the machine was interruptible, even in the midst of long instructions. Because we had done the architecture so you could do that. Amdahl was very antsy about the way we were talking about this, because he got up afterwards and said, well, an interrupt, just getting through the hardware is only the first part. You've then got to go through the saving of the existing status and all these other things. He just really didn't like the way we were talking about what we could do, which was a reflection on what the 360 could not do. Mm-hmm. Something he was a little protective about.
But he didn't understand interrupts either.
All right, well, that's, I think we've run out of time now.
Now it really has to go.
I want to thank all of you for joining us here and in this panel. I think it's been very interesting and lots of good stories and lots of interesting facts. So we really appreciate all of you coming in and taking the time to go and do this.
Well, we've enjoyed it too. Okay.
This will now be part of the permanent history of the Computer History Museum.
Right.
When people 50 years from
I have
now
your
want to hear about
email
what
address.
happened, this is what they're going to know.
Exactly. Who are these old guys?
Let's see. All right. Everybody managed to do
We all signed our,
You all signed your thing. Very good.
I'll send you an email, then you'll have mine.
This thing back.
God, brings back things I didn't know about. Was I there?
You want a Computer History Museum pen? I don't know whether there are.
He was going to leave it there.
That's what this is.
You can have that.
Yeah, the pen's for
It's
you.
a long one.
It's a souvenir.
I took it.
Good.
Well, thank you very much.
Thank you.
Really interesting.
I'm getting tired emailing you.
Where's your card going to keep? That's it.
That's yours.
Well, you made some of that final episode.
San Jose?
No. I was reminiscing of an email.
Where do you have?
I'm just going to San Jose Airport. But I was on the ride from
Then you have to take what's here on you.
American.
Then you have to take a bus.
That's for you. It's for you.
Very good.
It's not for me.
Straight there. San Francisco, get on a plane and take
The machine would crash. And I was the troubleshooter.
You were the designated.
Right. So
First thing is, it's all.
they come to me and said, what's wrong? Think to myself, there is no possible way on this earth that anyone could figure out.
I'm going to take off. Nice to be with you.
Nice to
Nice to see you.
Good to see you.
Arthur, thank you very much for coming and participating.
Yeah, it was a lot of fun. Thanks.
They wanted to ship this machine.
Yes, thank you.
Yeah?
And so I said to someone, what would happen if you switched to 66 or 67?
Nice to see you.
That affect the program.
I hope you.
So I did it. Ran all the way through. I said, ship it, goodbye.
What do you mean? It was true. You and I
Exactly.
Creative solution.
Yeah, a creative solution. Some things are not worth understanding. If you can fix it, don't bother understanding.
There is no possible way on earth to find out what went wrong.
Yeah, we should get together.
Thank you very much for coming and doing this.
And that's good to see you.
Jack?
Max?
You were separated.
So, well.